Friends, as you can see in figure 1, we have a point at 3, 2 and then another point at 7, 5. So these are just mere points. But what if I connect these 2 points somewhat like this way? So over here you can see now a right angle triangle. And what this particular triangle portrayed? Well, it portrayed that if you ran 4 unit on the right hand side, 1, 2, 3, 4, and you stood up 3 unit, 1, 2, 3, you frame this particular right angle triangle. But I would like to know what is this particular hypotenuse, or you can say what is the length of this particular line that you can see right over here. And I also want to know that what is the angle of this particular x-axis on x-axis. So in order to do this, what I have done is that I have written a small Python code snippet, but I have invoked the module called math. So let me show you one by one. As we saw over here, x comma y, x1 y1, we have a point which we have jotted down over here as 3, 2. So 3 is x and 2 is y, so we can write in this format. And we also have a point at 7, 5, and that is x2 y2. Okay, fine. Now what we want to see, these are just mere point, but I want to transform them into a form of a vector. So for that reason, what we are doing, x2 minus x1 we are getting dx, and y2 minus y1 we are getting dy. So that means we are differentiating between x2 minus x1. So over here, which one is x2? 7, and x1 is this. So 7 minus 3 we are getting 4, and then y2 minus y1, 5 minus 2 we are getting 3. So we are getting ultimately over here how much? 4, 3. So ultimately we are getting 4, 3. 4, 3. That's what we are getting right over here, and that's what we are getting in form of vector. Now a small verification we have to check over here is, before we move to the slope, and that is dx not 0, right? So we will check this particular thing. So if dx is not equal to 0, then we can find out the slope, and that's what we are doing right over here. So when we find the slope, we know the formula, y2 minus y1 divided by x2 minus x1, right? So y2 minus y1, we have already done that, and we have got dy, and x2 minus x1 we already did that, we got dx. So here is the implementation, and from this what we would be getting, it would be like 3 by 4, right? So when we get 3 by 4, 3 by 4 means 3 by 4, it would be equal to 0.75, right? Yes. So that's the slope which we got it. So from here we got the slope, or you can say it's also a ratio. So you can say it's a ratio, that also we can talk about. So we got the vector and we got the ratio, and now what we have to do, we have to find the length, right? So as I said, from this what we understood that 4, 3, that means we'll work on the right hand side, or we'll ran right hand side 4th step, and then we'll rise up 3 unit. So that's why it's called 4, 3, and that's what we got in the vector also. And from there we got the slope. Fine, good to go. Now we have to find the length, because we know very well when we talk about a vector, it has got 2 things, a magnitude and a direction, that in which direction the angle falls, actually in which quadrant it will fall rather. So first we will find the magnitude. So you have to find the magnitude. What we have to do, we have to give a call to a very popular formula which we know, that is under root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so this we are going to write it in form of Python, and for that reason we are giving a call to the math dot square root, because it's under root of x2 minus x1. x2 minus x1 is dx, so dx x2 minus x1 whole square. So this entire thing whole square, that's the reason we have written dx. the asterisk sum twice and then 2, it means it's a whole square. And similarly, the other part would be plus y2 minus y1 whole square. So y2 minus y1 is dy, so dy whole square with the help of double star. So ultimately, after doing this, what we'll be getting over here, we already saw that this is 4, so 4 square would be 16, and this is 3, so 3 square will be 9, so 4 square is 16 and 3 square 9, so 16 plus 9 would give us 25, and 25 whole square would give us actually the value 5, right? We'll get the value 5 exactly. This is the length. So this is the length of the vector. As we said, the vector comes up with true property. It has a length and a direction. So in order to find the direction, what we have to do? Now we have to find the angle. Right. So in order to find the angle, math provide us a special function that is called a tan 2. Well, why are we using a tan 2? Well, we don't know the angle initially, right? But what we know is that we know the slope. So here I would give a call, that means internally what this particular function is doing is that it is giving a call to tan inverse of 3 by 4, right? 3 by 4. The tan inverse of 3 by 4 is actually 0.75. So basically we can write in this way, like tan inverse of 0.75 is what we are trying to find out, and this will give us the angle that is something like somewhat around 36, something like there is there. Exactly when you run the code we'll get to see. But why are we giving a call to? We could have done that manually also. No, we did. It's not preferable to do it manually because we don't know what would be the value of it will be in the positive or in the negative. Right now both are in positive, so it is falling in the quadrant 1. Had this been negative, if the x is negative and the y is positive, it would have been in quadrant number 2. So the quadrant, and what if the both are negative, then it would be quadrant 3. If the one is positive, the other one is negative, then it will be quadrant 4. So there is a quadrant that will come in picture, right? And because of that quadrant, and again we already saw that what if the x is 0, that also is a concern. So keeping these two things in mind, the quadrant, the sign part of the points and which quadrant will fall, it is always preferable to give a call to this particular function that is called a tan 2. So once we give a call to a tan 2, from here we will be getting the radian. But we have to convert the radian to degree, and for that reason there is a special function called degrees which will convert this into a degree form, and here we are getting the degree out of that. So radian converted to degree form is what we are getting right over here. And now we are going to print all these information which we have come across. So let me now run the code over here, and here it goes. My file name is that tan underscore trigonometry. I hit the enter. The moment I do that, as you can see over here, the point was the point of A. This point is 3, 2, and the point B is 7, 5. That's what I have written over here. The vector which we saw was 4, 3. We saw the vector coming from this particular formula. We got to see the vector over here. Then we calculate the slope, and we calculate the magnitude, the length of this particular hypotenuse. We calculated that, and then from here we got the radian. So the radian value is this, and we convert the radian to degree. Yeah, it was 36.86 approx to 87. Okay, so this is what the degree is providing us. So from this particular program, what I try to show you, well, initially this was a geometry. This geometry we transform it to trigonometry in the form of tan inverse. From trigonometry we got the vector, and which is very much required for the purpose of doing computer vision. So from vector we can easily move on to computer vision. So this entire journey of using geometry to trigonometry to vector and to computer vision is what I was trying to figure out. Because over here which you saw this gx, I mean this x1, x2, or this dx and dy, this can be represented in the form of gx and gy, and they would be considered as gradient vector in the field of computer vision. So dx and dy will be considered as gx, and gy, it will be considered as gradient vector. Over there also we have to find the magnitude, which is basically the edge strength. We call it as an edge strength, and we also have to find the angle, which is called the edge direction, in which quadrant it is coming across. So all these terms will very much be often found in computer vision. So I wanted to show you that how exactly the geometry is giving the dimension to computer vision. That's what I try to put forward in this particular video and through this particular like the graph illustration, and then I showed the program part and we got the ultimate output from here. Okay, I hope this particular video will be helpful in understanding that how exactly vectors come in picture, and eventually we are moving toward the world of computer vision. Okay, so that's all from this video presentation. See you soon. Bye bye.